Hello everyone, welcome to another session of operating systems. So in this video, we will be covering the topics of system calls, structure of operating systems and concepts of virtual machines. So we'll start the first topic, that is system call. Now, what do you mean by a system call? So a system call is a mechanism that allows a program to request a service from the operating system's kernel. Normally, a system call provides an interface to the services that are made available by an operating system between a running program and the operating system, enabling the program to access hardware resources and perform the system level operations that are not directly accessed by the user space. Uh, these are the common categories of the system calls, where you can see the process control, file management, device management, information maintenance, and communication. The first one is process control. So in this process control type of system call, it deals with the how we are going to create a process, how we are going to terminate a process, and how we'll be getting the process attributes, and we are setting how we'll be setting the process attributes, wait event, signal event, allocate and deallocate the memory which is allocated for the process. So these are all dealt in the process control system calls. Here you can see the different functions which we'll be using in the process control. The first one we have is fork. So normally the fork is a system call which is used to create a new process by duplicating the current process. The second one is exec, which replaces the current process image with a new process image. The third one we have is exit, which is used for terminating the process. And the fourth one we have is wait, which is used for making the child process to wait for termination. The second type of system call is file management. So this deals with the creation of the file, how we'll be deleting the file, how we'll be opening and closing a file, how we'll be reading the data from the file, and how we'll be writing the data into the file, retrieving the file attributes, setting the file attributes. All these things comes under the file management system call. So here you can see the different functions. The first one is open, which will open a file. The second one is close, which will close a file. Third one is read, which reads the data from a file. Fourth one is write, which writes the data onto the file. And the next one is lseek, which repositions the file offset. Next, we have device management system call. So device management, here it deals with requesting a device or releasing a device. That could be an external device, getting the device attributes or setting the device attributes, logically attaching the devices or detaching the devices. Now here you can see the first system call IOCTL, which performs the device specific input output operations. The next we have read the data from a device. Next we have write, which writes the data to a device. The next category of system call is information maintenance. So this in this type of system call, we can get the time or date, or we can set the time or date. We can get the system data or set the system data. We can get the process files or device attributes, or we can set the process or a file or a device attribute. So here you can see the three functions: get PID, which will return the process ID. Next we have alarm, which sets the alarm clock for the process. Next we have sleep method, which suspends the process execution for a specified duration. The last system call we have is communication. Now this communication system call is used to create or delete the communication connections, or send and receive the messages, or you can transfer the information, and you can attach or detach some remote devices. The first function you can have is pipe, which is used for creating a pipe for inter-process communication. So inter-process communication here deals with the communication among the process. SHM get function, which allows the shared memory segment. MSG get, which allocates the message queue, and SEM get, which allocates the semaphore set. Now these are the different types of system calls you have. and here you can see the sample system, sample program in the C, where you can read the data from to the file and you can print the content from the file. Here you can see open, which here open is a system call, and here this is example.txt file, which is already a text file which is present, and o underscore read only. Now this one, the permission is given for reading only. So if the file descriptor is assigned with -1, then there is an error. Then we get a message saying that error in the opening file. Now here this is the method, read method, used for reading the data from the file. Okay, so here printf file content. Now here we are going to print the content of the file. Now this is a basic system call example in a C program for opening and reading the file. Normally in the system call, if we want to read the data from the file, we need to have a source file, we need to have a destination file, where you are going to take the input from the source file, write the prompt to the screen saying that give some data or read the data, or you can say it as an accept and input. Now next we need to acquire the output file where we need to copy the data. Now if the input file doesn't exist, then we are going to abort. If the output file doesn't exist, then also we are going to abort. Now this is the kind of system file process which copies the content of one file to the other file. Next we have structure of operating systems, which is very important concept. The structure of an operating system defines how its various components are organized and how they will interact with each other. Now here you can see the 5 categories of structures. The first one is monolithic, the second one is layered, third one is microkernel, and fourth one modular architecture, and fifth one is hybrid architecture. So monolithic architecture. Now as the name itself says, single, mono means single. So in this kind of operating system, the entire operating system runs on the single program in the kernel mode. So all the basic services such as process management or file management or memory management or device management, any kind of management mechanisms are included in one large block of code, and this structure is straightforward but can be difficult to manage and debug due to its size and complexity. The examples of monolithic architecture are Unix and Linux operating systems. The second one we have is layered approach. So as the name itself says, layered. So here you have different types of layers like layer 0, layer 1, so on up to layer n, each built on the top of the lower layers. Each layer interacts with the layers directly below it and provides the services to the layer above it. Normally the bottom layer, that is layer 0, will be the hardware part, and the highest layer, that is layer n, will be the user interface. The example of this layered approach is the operating system, so which is designed by Edsel W. Dijkstra. Next kind of operating system or structure of operating system is microkernel architecture, which minimizes the kernel by moving as many services as possible to the user space. The kernel includes the essential services like low-level memory management or inter-process management or basic scheduling, and the other services like device drivers or file systems and network protocols run on the user space. So the example could be QNX operating system, MiniX operating system, and Mac operating system. Next we have modular architecture. As the name itself says, modular. So we have some different modules which are dynamically loaded. So this structure allows the components to be added or removed without affecting the entire system. It combines the aspects of both monolithic and microkernel architectures. The examples could be Linux and Solaris operating system. Next we have client-server architecture. So in this category, the operating system is divided into client and server components, where the client components includes the user interfaces and the application level services, while the server component handles the core system services. The communication between client and server is done through message passing. So message passing is a concept where we have in operating system, where we will be dealing in the coming videos. Next, we have the examples of this client-server architecture is Windows NT and some implementations of Unix operating system. Next, we have hybrid architecture, which combines hybrid, as the name itself says, combination of n number of architectures. So, hybrid architecture combines the elements of monolithic architecture and microkernel architectures. They use core microkernels for essential services but allow other services to run in kernel mode for the performance reasons. The examples will be the modern versions of Windows operating system and Mac operating system. So next, we'll see the concepts of virtual machine. Normally, what is the meaning of the word virtual? So virtual means which is not present, but we are assuming that it is present. Now, virtual machine is also a software emulation of a physical computer that runs on an operating system and applications just like a physical machine. This virtual machines provides a way to run multiple operating systems on a single physical hardware host, allowing for greater flexibility, isolation, and resource utilization. Now, what are the benefits of virtual machines is resource utilization. Now, this single virtual machine on a single physical machine can be accessible with n number of hardware resources. Next, we have flexibility, where we can which is easy to create, configure, and manage virtual machines. Next, we have isolation. The virtual machines operate independently, enhancing the security and stability. Scalability. Scalability means improving. So simplify scaling up or down by adding or removing the virtual machines as needed. Cost saving, which reduces the hardware cost by consolidating the multiple workloads on the physical machine. So this is the end of the video. Now in this video we have learnt what is a system call, what are the types of system calls, and what are the different structures of operating system, and what is the concepts of virtual machine. Thank you.